Alrighty, so this is a little bit of a spontaneous video that I decided to make today. And the point of this video is to record my thoughts on the entity component system and map to how we would think about it from the database perspective. So for those who don't know what an entity component system is, it's a system where basically we have objects or a game. It's usually used in game development, and the way that it works is that we have a lot of these different objects in the game world. For example, we might have a character, might have monsters, we might have objects, colliding objects, projectiles, stuff like that, and we could represent those objects as entities. So representing objects as entities, and then these entities basically would have different components which represent different aspects of each entity. So for example, if we have a character, they might have, for example, a health component. So by components, I'm just referring to basically data classes or structures that are meant to just store basic data. So for example, for the health component, we might just store the current health, and that might be like a double or something. There might be other components too, for example, movement speed, which tells us how fast the character moves. There might be like attack, so like how much damage an attack will do. So like damage, which could be double, and etc. etc. Right? So they're basically these entities have all these different components, and these components describe the different states that that entity has. And by entities, what we mean is that usually they would be referred to as with some kind of ID. So they would just be given some kind of ID, like represented by a long or an int, depending on how you would like to implement it. And so entities are referred to by that ID. And so alongside with entities, there's a system component to this as well, right? So for the system, what it is basically like an interface where you would iterate through a subset or iterate through all entities, and then you would modify their components. So these systems, sometimes you might not want to iterate through all the entities. Instead, oftentimes you would usually just iterate through the entities that you care about. So for example, you could have a gravity system which affects the character. So in which case you would only iterate through all the characters of that game world. So a system could also iterate through what would be referred to as a family. And a family is just like a subset of all entities that match some kind of predicate or predicates, because there might be more than one. So for example, we might have a family of entities that have the health component, attack, movement speed, and then we might want to do stuff to those entities. So the system, something to note. So the system usually, when it runs through the game loop, and basically you call this update, so like update method, where you're provided the delta time since it was last ran. So basically you iterate through all of the entities that you care about. It could be a family, and then you would update them using the delta time. So given how much time has passed, what would you like to do with those entities? So for example, if your character is currently in a falling state, you might want to apply some gravity and affect its position, right? So you might want to move the position of the entity down depending on what the gravity of your world is. Okay, so yeah, there's way more to talk about in terms with entity component systems. You can also implement listeners. So there would be listeners for when you there can be listeners for any arbitrary thing that you can think of in this entity component system. So like whether you add, remove components from entities. So that's something you might want to listen to and then act upon. So for example, if your character is dead, then you might want to remove all of the components for that entity because you want to remove it away from the game world. And so maybe you could have some kind of like life counter state in the background, and so it decrements the life counter because you're listening on whether these character entities were removed or not. So that's something that you can do. You can also do a bunch of other stuff. There's listeners for when you're adding or removing components from entities. There's also listeners for when you add or remove entities themselves. Right, that's something you could do. There's also a bunch of arbitrary stuff as well, but I can't think of anything on the top of my head. But yeah, trust me, there's way more to entity component systems than this, but I think this is a good overview so far. Alright, so let's go ahead and talk about the database perspective. So how would we think about this from a database point of view? So in a database, what you would do is you would have like a table, and inside of this table, so imagine I have something like this. We have our primary key, so this could be like the primary key, which represents, this is a unique identifier for each row. So from the entity component system point of view, you can think of each entity ID as being a primary key. So this is like analogous to the entity ID. And then in the table schema, you might have these columns that have various data in it. So for these other columns here, you can think about these as components. So for example, we might have like the attack component. So this is saying for this one, this has 30, this does 30 damage, this does 20, 10, etc. This might be the health. This could be like 100, 50, and there might be components that are only available or that you only add to some certain types of entities. So for example, you might have a character, an is character component. So for this one, it might be true, but if you don't set it, it could be null as well, right? So in from the database point of view, all of these components you can think of as basically columns in the table schema, which dictate what data corresponds to that entity for that row. Okay, and then in terms of like a family, you can think about this as being indexes on that table. So for example, you might want to define a family that always has the health component set and the attack. So then for that family, or not indexes, but like this is a view on that table. So then this is a much faster and more optimized way of just basically iterating through all the entities that have these components. So this would be health. This would be, what the heck did I write here? Okay, this is attack. Attack, put some random numbers. Right, so that's how you can think about a family from the database point of view. So yeah, that is basically how I think about it. So in terms of implementation, there are so many different ways to implement it. So for example, you can have a set for all of the set of all active entities right now. So for example, just a set long, where the long is just the entity ID. For the components, what you can do, there are many ways to implement that as well. But for a single entity, so like entity, what you can do is you can basically store a map for that entity of like the component name to component instantiation. So like what this would look like is you have the map, the health component, which points to the data class object, which has all the data, and then the API basically just has getters and setters for adding or removing components. So this is a very trivial way that you can implement these entities. And for a family, by the way, in practice, you usually don't want to do this because using a map is really slow because of the random access that is involved in it. Usually, another way that you can do it is that you can have like a component container for one of these components for like health. So this would be like a generic class, and then it would have an array basically to the component instantiations, and then the index would be equivalent to the entity ID, so that you can get really fast lookups for these components. So yeah, there are so many different ways to implement it, but just letting you know. So this is one way, this is another way. I'll leave it as a homework to the viewer to think about how you would implement a family of entities. So basically you want something that is auto-updating. So as you add or remove components, then you want to iterate through all of the family configurations. And if it matches that family, then you want to add it into that set for that family. If it doesn't, then you remove it. Stuff like that. But yeah, it's pretty fun to implement an entity component system. I would definitely recommend you trying this out yourself. A great example of one I know is called Flex. This is for Kotlin. Shoutouts to the Kotlin crowd. Definitely check out that implementation because it's actually pretty straightforward to read. And they have like a bunch more optimizations for how they implement these different features in an entity component system. Okay, I think I'm going to stop the video here, and I hope this helps in the future. If I get dementia and I forget about the entity component system, I could just look back on this video. Okay, thanks for watching, bye.